Students, in our control system laboratory, you have to use the setup of Matlab. Okay. Now see, there is a small icon here. That is called Matlab. Okay. So if you double click on this Matlab, and it is now opening, and this window is opened. Okay. So you can do different kinds of experiments, different kinds of simulations, different kinds of mathematical calculation by using the Matlab. Okay. And see, this is a program arrow is mentioned here. I think you are all seeing this cursor. Suppose if I say what is the time, if I say what is the time, it is not mentioning any time. See, it is mentioned here undefined function or variable time. Now if I say in terms of computer, if I say clock, then you see a digital kind of timing, it has been mentioned, it's been shown here. Okay. Now these are all about the introduction of Matlab, plus the experiment number 1, that is familiarization of the Matlab control system toolbox, that we will find today. Okay. Now if I write about date, and if you press enter, then you see it is showing 19 May 2015. Okay. So as it is a old version of Matlab, okay, and this version is already expired, so we have given this time before to 2016, so that's why this is time is mentioned 19 May 2015. Okay. Now say if I ask about, say we have already discussed about what is transfer function. Say suppose I am writing the transfer function, TRANSFERFUNCTION. Now you see it is shown that undefined function. As I told you on the last class, that there is a comment is there that TF, if I say TF, it is showing empty transfer function. So you have to define some values. So if I write here help TF, then you see different kinds of function has been shown here. Okay. So different kinds of function has been also system equals to TF numerator comma denominator. So these are all these showing of how you can form the transfer function, right? How you can form the transfer function. Now you see, now to erase this, I will simply put clear all. If I put clear all, in that case whatever the memory we have given here, all those memories has been removed. And then if we put here CLC, in that case it will clear the screen. Now to form a transfer function, we have to define the numerators, we have to define the denominators. Suppose if I consider that a function is, say, first order. So first order means, so in case of order, what do we know? In case of first order, say a transfer function GS will be equals to, say 1 by s plus 2. Okay, a function is 1 by s plus 2. So that means in the numerator you have 1 and the denominator you have s plus 2. So now you have to define the coefficients in matrix form in the Matlab. So now how I am showing to you. Say n1, I am writing n1 equals to 1. Why I have written 1? Because I have taken the function as 1 by s plus 2. So nothing but it is nothing but 1 into s to the power 0. So is 1, enter. So it is showing n1 equals to 1. Then d1, I'm writing like this, d1 equals to, I am giving third bracket, 1 space 1. Why? Because 1 space 2, because we have taken here a first order system and it is s plus 2. So it is actually defined with 1 into s to the power 1 plus 2 into s to the power 0. That's why it is coming 1 and 2, and if you give enter, it is coming 1 and 2. Now if I give a variable that is g1 equals to the command is transfer function tf, give first bracket, then you write n1 comma d1. Okay, so in that case you will get here, you give enter, so it is the transfer function has been shown, it is 1 by s plus 2. Similarly, say if I go for another transfer function, say we want to define, say s by, say suppose we are that s by s plus 3. So in that case how we will write? So this particular parameters will not take again, this particular parameters will not take again. So you will go for n2 equals to, say I am told that it is s, so I'm right, I'll put third bracket 1 space 0. So when I'm giving this is 1 space 0. Okay, so this cat is coming at 1 and 0, so it is s to the power 0 into 0, so it is 0 plus s to the power 1 into 1, that means it is coming as s, and the denominator d2 equals to I have written here that denominator is s plus 3, so I am coming right 1 space 3, so and give third bracket. Okay, and now give enter, so it is coming, see, 1 and 3. So if I now if I write g2 equals to tf first bracket n2 comma d2, so this will give you s by s plus 3. Okay, this is s by s plus 3. So first you got one transformation, that is 1 by s plus 2, another transformation you got s by s plus 3. Now in our regular classes we have already did series function, the series combination and parallel combination, right? So suppose this g1 and g2, this g and g2, if they are connected in series, what do you know? That their overall combination will become multiplication. Say if I write g series, so the series combination of this g1, series combination of g1 and series combination of g2. So g underscore series will be equals to, you will write the command as series, series, series command of g1 comma g2. Now so you will get s by s square plus 5s plus 6, that is nothing but the multiplication of 1 by s plus 2 into s by s plus 3. So you see s into 1, that is s, and s plus 2 into s plus 3 is coming as s square plus 5s plus 6. Okay, now if I consider that we need the parallel combination of g1 and g2. So yes, we have already did in the class parallel combination. So I'm writing here G underscore parallel is equals to the common I've given here, parallel of G1 comma G2, and you will see when you give the command parallel parallel G1 comma G2, you will get the addition of this G1 and G2. Okay, this will give the addition. So 1 by s plus 2 plus s by s plus 3, so you will get this function. Okay, I think this thing this thing is already clear to you. Okay, now if I want to find that pole zero map of the transfer function G2, okay, so let we try if we put here ZPK. So if we put here ZPK of G2, okay, if we put here ZPK of G2, you will see it is coming as G2 means G2 is your S by S plus 3. So pole 0 pole gain is coming S by S plus 3. Okay, and if you put here PZ map of G2, you will see we'll get a position. Just a minute. Now you will see. So PZ map of G2, it is coming here. See, we know that poles are represented with a cross sign. So this is a cross sign here. So here we having a pole at S equals to minus 3. If you see this, S equals to S plus 3 equals to 0. So S equals to minus 3. So at minus 3 we are having a pole. Another one, the 0 is present at A, making the numerator as 0. So S equals 0. So it is 0. So this is the pole location. Sorry, 0 location. So this is the pole 0 map. What we can find out from the transfer function. Okay. Similarly, if I say PZ map of this latest function, that is G underscore series, G underscore series. So here you will get two different poles. Say we have discussed, one is S equals to minus 2, another is S equals to minus 3, and another pole is another 0 is present at S equals to 0. So here you will have the pole 0 map. So I think up to this is clear to you. Okay, so I am stop my recording.